Okay. Okay, all right. So we started off with the thermal radiation, right? And we discussed the definition of the electromagnetic wave as well. Okay. And we we discussed that frequency and wavelength of different electromagnetic radiations are different, and their uses are also different, right? Uh, we also had a discussion around temperature, surface area, and color texture. ठीक है. और उसके बाद we were discussing about how radiations can be reduced. ठीक है. अच्छा जी. Then we also discussed this example where the three processes can be observed, right? Conduction, convection, and radiation. And then we saw the cooling curve and the heating curve, right? ठीक है. Today we will be discussing about the infrared emission of infrared, ठीक है, with respect to the graph, ठीक है. So that can be the part of the investigation. All right. Acha, we did one question from the past paper question, ठीक है, from the past papers. That was this one. A type of nuclear reaction takes place at the center of the sun. The reaction releases thermal energy, right? So this was done in the previous classes as well. Uh, right. So there was a question that described the radiation that is emitted from the surface of the sun. So the process needs to be described here. So acha, one problem was also done. Okay, so we are going to start the emission of infrared radiation and um, absorption of infrared radiation. Okay, ठीक है, तो हम उसको ग्राफ के रिस्पेक्ट से देखेंगे. अच्छा, we did these MCQs as well, right? You remember? A copper rod is heated at one end. ठीक है. So can you tell me that has it been uploaded on YouTube? ये अपलोड कर दिया था ना मैंने? I
Yeah,
must
he
have that.
uploaded.
ये uploaded है ना?
Yes.
Okay, all right. जज़ाकल्लाह. ठीक है. Okay, so rest of the questions are required to be done from your side because ये आप एक kind of assignment ले लें और इसको फिर करें. Okay, ठीक है.
Yes.
Um, all right. So emission of infrared radiation. Uh, First of all, the very first point is that we know that all objects and surfaces emit radiation, right?
Yes.
All objects and surfaces emit radiations, right? So so because of this radiation emission, right? Because of this emission, the temperature of the, what do you think, what is going to happen? Temperature of the object is going to fall or rise? Yes.
The temperature will rise.
Emission only. Emission means that the energy is going to be lost, right? So
Fall.
so temperature of the object falls. Okay. So if we are going to observe to the nature of the surfaces that which object is going um, to emit the radiations quickly, right? So let's say that uh, there is one container that is of the black one. Okay, let me draw the black one, right? And we are now going to connect a temperature sensor. This is temperature sensor, right? So the temperature is going to be monitored, okay? Okay, or we can say that the temperature is going to be monitored continuously. And over here, we are going to have a shiny surface or shiny tin, right? And over here, and another temperature sensor is there, okay? So the you can see the temperature sensors are monitoring or sensing the temperature, right? And they are giving the reading to the data log, right? Now what are we going to observe over here? This is going to be a black tin, and this is going to be a shiny tin. What are we going to investigate? That which one is going to whose temperature is going to fall quickly. Okay. Okay. So if we, after investigation, we get this curve, right? So what are we observing here? They both reach to room temperature, right? And this is your time that the time is taken on x-axis and the temperature is taken on y-axis. So the thing that you have observed, that you have to identify, um, that this is going to be a black tin. This curve is for the black tin, right? This one is for the black tin. And this is for the shiny tin. Now you are going to tell me that how are we going to identify that which one is emitting the radiation quickly. If we compare the graph, or if we select 2 points, let's say, let me call this T1 and let me call this T2, right? And if I select this point and this point, so now in that T1 point or T1 seconds, right? Or it could be minute, it could be an hour. So what are you observing here? Okay, in that specific time, the black 10 is having less temperature and the shiny 10 is going to have more temperature at this
Yeah.
particular time. Okay, right? So this is how we are going to identify that black 10 is going to be a good emitter. Okay, because it is emitting quickly and the temperature falls quickly, right? Or when we talk about at T2, again we can see that still there is a difference. और अगर हम T2 सेकंड पे भी देखते हैं, अगर कोई टाइम है हमारा T2 कोई टाइम है, at this same time, if we compare the temperatures again, तो we can see कि यहाँ पर भी टेम्परेचर ब्लैक टिन का जो है वो कम है और शाइनी टिन का भी ज्यादा है थोड़ा सा. So this is telling us that the black tin is a good emitter. So now what could be the conclusion? Yes, beta. Conclusion क्या होगी हमारी? Conclusion is going to be dull and black surfaces emit infrared radiation at a faster rate. Okay, then a shiny and silver surfaces. I hope this is clear to you, right? Any confusion till here?
तो सर वो सिर्फ ग्राफ का मुझे ये समझाएं कि लेकिन ग्राफ में आपने खुद लेबल किए हैं यहाँ पे, ये ग्राफ में हमें दिया हुआ होगा कि ब्लैक टेन नीचे वाला है और शाइनी टेन ऊपर वाला है.
नहीं, ये अगर नहीं भी दिया जाएगा तो देन वी कैन इजीली टेल. अगर हमें ये नॉलेज है ना कि the black surfaces are the good emitters, then on the basis of this information we can decide that the curve which is drawn below is going to be a black 10. Okay, क्योंकि
यस सर.
either of the information should be given. ठीक है, maybe they can give us the black 10 and shiny 10, and then they can ask us that what are you observing, ठीक है? Or they can give us that we are going to decide that which graph does belong to a black surface or a black object, and which graph should be should belong to the shiny or any silver or reflecting surface. Clear?
Yes,
Okay.
sir.
This is how they can ask. All right, now we are going to talk about the absorption of radiation, infrared radiation, right? Absorption of infrared radiation. So our next discussion is around absorption of infrared radiation. Okay. Now, again, we are having one shiny uh, surface. Okay. And there is a temperature sensor. Right. And the mm, same type of a material or a rod is given here. Uh, and there is a thermometer or a temperature sensor, and this is connected to the data log, and continuous reading is observed. And the graph that we get after this experiment, the time in minute or a second, right? और यहाँ पे हम टेम्परेचर ले लेंगे in degree Celsius. Okay. Now the both objects have started from the same temperature. Okay, and both are receiving the thermal energy. Okay, this one is getting thermal energy. Clear? And this one is also getting thermal energy. And we are on the basis of which we are going to observe, right? We are going to observe that which one is getting more thermal energy. Yes, so it is given to us that this one is a shiny one, shiny foil or shiny rod, right? And this one is the blackened one. Okay, blackened foil, right? So what are you observing? What are you observing at a particular temperature? If you are here at at a particular time, if you are here at T1 seconds or minutes, yes, it is written here in minute. That means that we have to talk about minutes in T minutes. So what is the temperature? What are you observing? What is the temperature at T minutes? Or in T minutes, what is the temperature the both foils have attained? The first thing, have they got a different temperature, or um, are they at the same temperature? G, are they at the same temperature?
Sir, no.
No. So which one is having a greater temperature at T
The
minutes?
black.
The black one. So this indicates
Yeah.
the black surfaces gain more thermal energy, right? So that means the black surfaces are good absorbers. Okay. So after this in experiment, we can conclude that uh, we can conclude. So this is going to be our conclusion that uh, the blackened foil, the blackened foil, or we can say the black surfaces are good absorbers of infrared radiation. they get more heat. Clear?
Yes, sir.
ठीक है. So as compared to which one, beta?
Black soil.
Yeah, as compared to a
Very
shiny or silver surfaces. Right. I hope this is now clear to you.
Yes, sir.
Now we are going to talk about some applications of transfer of thermal energy, where the useful, the transfer of thermal energy is useful in our daily life, right? So application of transfer of thermal energy, right?
अब कैसे काम करेंगे?
Now, good conductors of heat, like we need good conductors. We need good conductors of heat for cooking utensils, right? Right. So, for example, kettles, saucepan, and boilers, right, are usually what are usually made up of aluminum or stainless steel. Okay. The second thing, you must have seen the PCBs, right?
What?
Okay. Right. So you must have seen this, right? Printed circuit board PCBs. Okay. This one. Can you see this one? This thing?
Yes, sir.
Okay. You must have seen this one, this thing. Okay. This thing. Right. So this is the this one is soldering iron. Okay. This is what? Soldering iron. Okay. Soldering iron, right? And the soldering iron rod should be in soldering iron. Rod should be made up of better conductor of heat or a good conductor of heat. Okay. I should write good conductor of heat. Made up of good conductor of heat, right? like copper. Okay, so that um, you know it can bear more temperature. Acha, again the transfer of thermal energy is useful in heat exchangers, right? Okay, so the heat exchangers in the heat exchangers are used in where? In laundry services or facilities. Okay, so it is required. It is required to warm. It is required to warm um, and to clean to and to clear the water or clean the water, right? We can say clean or clear, right?
सर
What?
समझ नहीं
Sorry.
सर समझ नहीं आया
अच्छा, तो आपके जो मशीन्स होती हैं, जो लॉन्ड्री के लिए मशीन्स यूज होती हैं, उसके अंदर ड्रायर होते हैं, ड्रायर।
जी
तो ड्रायर में क्या होता है? हीट एक्सचेंजर्स लगे हुए होते हैं। ओके,
जी
तो हीट एक्सचेंजर्स क्या करेंगे? अगर वो हीट एक्सचेंज ही नहीं करेंगे तो विल देयर बी एनी
नहीं
इफेक्टिव ट्रांसफर ऑफ थर्मल एनर्जी? क्या
हाँ
वो
सर
इफेक्टिव ट्रांसफर ऑफ थर्मल एनर्जी होगी? नहीं होगी। क्लियर?
नहीं,
अच्छा जी, हीट रिड्यूसिंग का हम लोग देख देख चुके हैं। ठीक है, कि कहाँ पे हीट रिड्यूसिंग का हमें ज़रूरत होती है। ठीक है, जो हैंडल्स होते हैं आपके यूटेंसिल्स के, कुकिंग पैन्स के, दे शुड बी मेड अप ऑफ इंसुलेटर्स, राइट? ऐसे
नहीं
ही।
सर
ठीक है, सो यूज ऑफ इंसुलेटर्स, यूज ऑफ इंसुलेटर्स लाइक हैंडल्स
सर
हैंडल।
उनमें भी थर्मल एनर्जी पास होगी लेकिन बहुत स्लोली होगी
यस, ठीक है, ना होने के बराबर होगी जब तक हमारा काम हो चुका होगा। ओके, सो हैंडल्स ऑफ यूटेंसिल्स, ठीक है, आर मेड अप ऑफ insulators to prevent injury or damage, right? Or burning, we can say burning of skin. Okay. अच्छा, आपने कुछ ऐसे वॉल्स देखे होंगे जिसके अंदर डबल ग्लेज विंडोज होती हैं। ठीक है, लेट मी शो यू हेयर so that you can get a better idea. Now you can see the double glazed windows. Okay, this thing. So the two-sided windows, right? So the air is trapped. Air is trapped, right? Air is trapped between these two glasses, right? Okay. So what I'm going to write here, air is trapped between two uh, pans of glasses, right? For what purpose? To reduce the thermal energy. To reduce the thermal energy through the windows. Clear? Um, all right. Acha, where the air conditioner system or AC should be installed?
Sir, on the top.
Yeah, air conditioners की हम example ले लेते हैं. So these are always installed near the ceiling of room. ठीक है, or on the top of room, so that to um to make convection current, right? So the cold particles
लेस डेंस हो जाते हैं.
can reach the ground or floor,
Yes.
right? Because cold air is denser, right? Cold particles are denser and the warm air is less dense. So they rise. Yeah. So this is how the circulation of the cold and the hot particles are, the circulation of the cold particles and the hot particles is possible. Yeah. ठीक है. So I also spoke about the application of radiation in the vacuum flask, right? Design of the vacuum flask, that the plastic stopper should be there in order to stop the convection, right? The stopper reduces the heat transfer by conduction, convection, and evaporation. Okay, so the stopper needs to be there. Okay, this thing. The stopper has to be there. Okay,
Yes.
right? अच्छा जी. अच्छा, वैक्यूम did I talk about the vacuum as well? Yes, vacuum के बारे में बात की थी ना मैंने.
ठीक
ये
है.
रहा vacuum. So vacuum, what does vacuum do? The vacuum between the double glass walls of the flask,
सर
it prevents the conduction and
reduces
convection.
loss of thermal.
Yes, it prevents prevents what conduction and convection through sides of the glass. Okay, ठीक है?
Yes.
Any confusion?
No, sir.
All right. So did I talk about the double walled glass of container? डबल वॉल ग्लास क्या कर रहे होते हैं? अभी बात की मैंने उसकी, उसके
हाँ सर,
अंदर
वो
एयर ट्रैप हो जाती है।
एयर को ट्रैप कर लेते हैं ताकि जो हीट अंदर आए
या
वो इतनी वार्म ना हो।
एक्सीलेंट, ठीक है, गुड। ऑल राइट, सो सोलर पैनल्स, अगर हम बात करें सोलर पैनल्स की, तो सोलर पैनल शुड बी ऑलवेज ऑफ ब्लैक कलर, राइट? ओके।
यस।
All right, so now we are done with it. So Alhamdulillah, the transfer of thermal energy is completed along with the application.
हाँ सर, वो असाइनमेंट दे दिएगा क्वेश्चंस का।
All right, take care. Okay, Allah Hafiz. Assalamu alaikum.
उससे